When solving systems of three variables, three equations, it's important that you just follow one rule. Whatever variable you pick to eliminate, you eliminate it using all three equations, combination of all three equations. So when I look at this question, it's probably the case that all variables are pretty equal in terms of which ones would be the best to eliminate. So I'm actually just going to choose x. Again, all of them are pretty status quo. They all have the same properties going on, but I'm choosing x. So that means I need to use all equations to eliminate x. I'm going to call them 1, 2, and 3 so we can refer to them. I'm first going to do 1 and 3. So you'll see me do this just so I know which ones I'm dealing with. And I tend to always rewrite equations so I don't get lost. So that's equation 1 with equation 2. So when I put both 1 and 3 together, the x's cancel, but so do the y, or the z, excuse me. I'm left with y plus y, or 2y, which is 3y, and a negative 1 and 4, which is 3. If I divide both sides by 3, I get y equals 1. So there's my first value. That was actually a way quicker solve than you'll see normally. Next, what I'm going to do is, because I chose to eliminate x in 1 and 3, my next job has to include eliminating x with equation 2. I don't have a choice. So I'm going to use equation 2, and then I'm also going to use equation 3 multiplied by 2. So again, what I just wrote down is my own notation so that I know what's going on. So equation 2 is 2x minus y plus 2z equals negative 5. I'm going to couple that with equation 3 after I've multiplied by 2. So equation 3 multiplied by 2 is a negative 2x plus 4y minus 2z equals 8. My goal was to use equation 2, because I hadn't used it yet, and eliminate x. So when I combine them, a negative y plus 4y is 3y, a 2z minus 2z cancels, and a negative 5 plus 8 is 3. Oh my, I'm left with the same exact thing I was left with before. I get y equals 1. So I've hit a dead end, and sometimes this happens. So I'm going to switch gears a little bit. Here's what I know right now. I know that y is negative 1. So I'm going to, whole new game of attack here. I'm going to take equations 1, 2, and 3 and write a brand new system as if my y value were a 1. I'm going to actually make that a 2, because if I multiply. And I'm going to take those values and combine them on the other side. Okay, so my first equation becomes x plus z equals a negative 2, because I'm taking the positive 1 on the left, that was y, and moving it to the right with a negative 1. My second equation becomes 2x plus 2z equals negative 4, because I have a minus 1 on the left that if I add to the negative 5 gives me minus 4. And then my third equation becomes negative x minus z equals 2, because if I move the positive 2 from the left to the right, it becomes a 2. I want you to focus just for a second on what happens here if I take equations 1 and 3 and combine them. Do you see that everything would cancel? In fact, I'd be left with a statement of 0 equals 0. That is a fantastic statement to have. This system is infinitely many solutions. This is not common. But the reason I wanted to lead with this example is because sometimes when this happens, we get a little frustrated and we kind of bail ship. But if you have things cancel, consider the fact that even when you have 3 variables and 3 equations, those dependent and inconsistent systems can exist. We won't graph them. Obviously, we're not in a 3-dimensional graphing state yet, but certainly something that can occur with equations. So I do want to put it out there. I know this problem was kind of crazy, but this is not common. It certainly can happen, but it's not common. All right, so let's do one that's a little bit more common. I'm going to start off the same exact way. I'm going to label this 1, 2, and 3. Looking at the variables, it almost looks to me like y or z would be better. I'm just going to pick y because it occurs first. So my first system, I'm going to do equations 1 and 2. So equation 1 is x plus y plus z equals 3. And equation 2 is 2x minus y plus 2z equals 6. So my y's do in fact cancel. X and 2x is 3x. Z and 2z is 3z. 3 and 6 is 9. I'm going to box this. You'll see I boxed that for a reason. Because my first choice was to eliminate y in equations 1 and 2, I must eliminate y using equation 3. And I'm actually going to use equations 2 and 3 because 2 already has a negative coefficient. So I'm going to use equation 3, and then I'm going to take equation 2 and multiply it by 2 so that my y variables cancel. So equation 3 is 3x plus 2y minus z equals 13. If I take equation 2 and multiply it by 2, I get 4x minus 2y plus 4z equals 12. So my y's cancel. That's my goal. 3x and 4x is 7x. Negative z plus 4z is 3z. And 13 and 12 is 25. As long as you use all three equations to eliminate the same variable, you will be left with two equations with the same two variables. So look at what I have boxed in both orange and green. At this point, I have two equations with both an x and a z. I can eliminate x and z. So I'm going to just recopy the orange one so you can see what I mean. If I take the green equation and I multiply it by a negative, I get negative 7x minus 3z equals negative 25. Can you see where this is headed? The z's cancel. 3x minus 7x is a negative 4x, and 9 minus 25 is a negative 16. So x is 4. Divide both sides by negative 4, I get 4. You can then turn around and flip that x equals 4 into either of the box equations. It does not matter. Either one to solve for z, the other variable. So I'm going to actually put it in the green one only because that's where I have some room. Take a second and write the green equation where x is 4. 7 times 4 is 28, plus 3z equals 25. If I subtract 28 from both sides, I get 3z equals negative 3. And then dividing by negative 1, or positive 3 gives me negative 1. Sorry, I was shooting the gun there a little bit. All right, all I need left is y. I'm just going to pick any of the first three equations to find y. I'm going to actually pick the first one because it looks the easiest to me. So in equation 1, if I put a 4 in for x and a negative 1 in for z, I get 4 plus y minus 1 equals 3. 4 minus 1 is 3 plus y equals 3. And subtracting 3 from both sides gives me 0. Y equals 0. Just like you can write answers as ordered pairs, you can write these answers as ordered triples. Just put them in alphabetical order. So x, then y, then z. You certainly don't have to, but that makes it a little bit easier to grade sometimes when your work is all over the place. So again, when you do these questions, there are two really big things to remember. The first, if you feel like you're stuck, try another avenue. The second, if you get to the point where you've chosen which variable you want to eliminate using two of the equations, make sure you eliminate the same variable using the third equation. That way you don't get in a rut like you normally could. All right, we will do one more together. When I look at this one, honestly, it doesn't really matter which one I choose to eliminate, so I'm just going to eliminate x, I guess. So the first thing I'm going to do is the equations 1 and 3. So I'm going to eliminate x in 1 and 3. Equation 1 is x plus y plus z equals 6. And equation 3 is negative x plus 2y plus 2z equals 9. So my x's do cancel. Y plus 2y is 3y. Z plus 2z is 3z. And 6 plus 9 is 15. Box that and use it in a minute. Because my choice was to eliminate x in equations 1 and 3, I must eliminate x in equations 2 and something. So equation 2, I see, has a positive 2x. It would be easiest to use equation 3 if I multiply it by 2. So equation 2 will stay as is. 2x minus y plus 3z equals 9. But I'm going to multiply equation 3 by 2. Negative 2x plus 4y plus 4z equals 18. So my x's cancel. Negative y plus 4y is 3y. 3z plus 4z is 7z. And 9 and 18 is 27. All right, you'll notice, and this should be the case if you did the first step correctly, that the two equations you get from eliminating should be the same variables. So you can eliminate those next. I'm going to keep the purple equation as is, but see, in my head I was working ahead, I'm sorry. But then I'm going to change the green equation by multiplying by a negative 1. So negative 3y minus 7z equals negative 27. So my y's cancel. 3z minus 7z is a negative 4z, and 15 minus 27 is a negative 12. If I divide both sides by negative 4, I get z equals 3. There's 1. You're going to want to turn that around and put it right back into an equation that you just had boxed. That's why I boxed them. They're easier to find. So I'm going to turn around and put that 3 in for z with the green equation, because I have some room there. 3y plus 7 times 3 equals 27. So I get 3y plus 21 equals 27. Subtracting 21 from both sides gives me 3y equals 6. So y equals 2. At this point, I've gotten a z and a y. So I'm just going to put that in any of the original equations. It doesn't matter which one. I'm going to choose number 1 because it looks the easiest to me. So x plus, instead of y, put a 2, plus, instead of z, put a 3. So I get x plus 5 equals 6, and if I subtract 5 from both sides, I get x equals 1. If you'd like to write this as an ordered triple, it would be 1, 2, 3. Please pause the video and complete the last question as a you try it. I strongly urge you to pause the video if you need to look over the solution. Please let me know if you have any questions or concerns.